Newton, let's continue our discovery of how celestial objects interact with each other through gravity in space.
Yes, I remember we had this marble orbiting the massive object in the middle. This massive object can be our sun, and the marble is some small planet or asteroid in the solar system.
Yes, do you see anything happening to the metal ball as the marble orbits it?
No, it seems totally oblivious to the marble's movement.
Great. Now, take this small metal ball and give it a push, Newton.
Okay, let me do that.
So now, what did you observe happening to the metal ball in the middle?
The large metal ball seems to be moving too.
Yes, it does. Now let's see that again. Okay, now let's try to use another metal ball of the same size as the one in the middle. Now let's see what happens.
Wow! Both metal balls orbit each other?
Indeed! That is awesome! Now let's try that again.
Yes! It looks so cool!
So Newton, the question is, when we were using the marble to orbit the large metal ball, did the large metal ball move?
No, I did not see it move at all.
Well, that's not entirely accurate. It actually moved, but because the relative mass of the two objects are very different, we can't actually see that the large metal ball actually moved too, because it was too tiny to be observable.
Is it?
Well, yes, it does. You see, but as this is similar to the tiniest objects in the solar system moving around the sun. As the mass is tiny relative to the sun does not seem to be affected by it. But once the two masses start to be close to each other, we can see that the two objects are actually orbiting each other. So we can see that the giant planets of Jupiter, Saturn, Uranus and Neptune actually cause what we call perturbations in the orbit of the sun.
Okay, why is that useful?
Well, we can use this to detect stars that have massive planets orbiting them. As the giant planets orbit around their stars, the star wobbles, and we can infer that the star has a planet orbiting them.
Planets orbiting a star cause the star to wobble. This wobble is actually due to the star orbiting in a small circle or ellipse. We can detect this movement by using highly sensitive spectrographs connected to Earth-based telescope. When the star moves towards the observer, the light detected shifted more towards the blue spectrum. When the star moves away from the observer, the light detected shifted more towards the red spectrum. In this way, we can detect massive exoplanets orbiting distant stars provided we are not looking particularly at the star, since we cannot see the star moving towards us or away from us.